Hello, everyone. Today, I'm gonna walk you through this lesson, and I'm excited to be learning with all of you. Last class, we discussed Modbus over serial communication. This time, we'll cover Modbus message transmission over TCP/IP. Modbus TCP is a variant of Modbus used for communication over TCP/IP networks, with a connection port of 502. There's no need for checksum calculations, as lower layers already provide checksum protection. The terminology for Modbus TCP is the same as for the Modbus serial line protocol. Any device that sends a Modbus command is a client, and the one that responds is the server. Modbus TCP frame structure. The Modbus organization officially refers to the ADU of Modbus TCP as the Modbus TCP/IP ADU, or Modbus TCP/IP ADU, also known as the Modbus TCP frame by other organizations. The Modbus TCP frame is shown in Figure 2.3. It includes the Modbus application protocol header, function code, and data. MBAP is the abbreviation for the Modbus application protocol header, specifically used on TCP/IP to identify the header of a Modbus application data unit. MBAP consists of 7 bytes with fields as follows: 2 bytes for the transaction identifier, 2 bytes for the protocol identifier, 2 bytes for the unit identifier, the length of the data PDU, and 1 byte for the unit identifier. Modbus TCP example. Let's take a Modbus TCP frame as an example. 1, 0 hex 12 and 0 hex 34. The transaction ID is 0 hex 1234, 2 bytes, which serves as a unique identifier between the Modbus TCP client and server. Here, the high byte of the ID is 0 hex 12, and the low byte is 0 hex 34. 1, 0 hex 00 and 0 hex 00 are the high and low bytes of the protocol identifier. 2, 0 hex 00 and 0 hex 06 are the high and low bytes of the length. The length is 6 bytes, which includes unit identifier, slave address, 1 byte, function code, 1 byte, high byte of the register address to be read, 1 byte, low byte of the register address to be read, 1 byte, and data, 2 bytes equals high and low bytes of the number of registers to be read. 3, 0 hex 01 is the unit identifier, slave address. 4, 0 hex 03 is the function code, indicating the reading of multiple holding registers. 5, 0 hex 00 and 0 hex 01 are the high and low bytes of the register address to be read. In this case, the register address to be read is 0 hex 0001. 6, 0 hex 00 and 0 hex 01 represent the high and low bytes of the number of registers to be read. In this case, the number of registers to be read is 0 hex 0001, i.e., 1 register. Next, we'll use Modbus slave and Modbus poll to establish Modbus TCP communication. Modbus slave will act as the server, and Modbus poll will act as the client. So, if you try to start the client without having the server up, you'll get an error just like in the video. Open Modbus poll. Close this window, and then connect again. Click Connect, select Modbus TCP/IP. For the IP address, enter 127.0.0.1, which is the local IP address of the computer. For the server port, choose 502, and keep the timeout setting as default. Click OK. Now we see a pop-up box that says, Modbus TCP connection failed. Connection timed out. So, we should first use Modbus slave to create the server before creating the client. Let's open Modbus slave and Modbus poll. Close the previous window. Modbus slave will act as the server, which is on the left, and the client will be on the right. First, create the server. Click Connect, select Modbus TCP/IP. Since we're creating a Modbus server on this computer, its IP address will be the local host address, which is 127.0.0.1, and the open port will be 502. Click OK. To create data that's accessible externally, click 6. Right-click on the top left corner of the table and select Define. Here we've set it up. For this server station address, the externally accessible function code is 03, which is for holding registers. We'll use decimal for the address. The starting address for the externally accessible data is 0. How many addresses will we open starting from 0? Choose 16. Click OK. This creates data addresses from 0 to 15, which are 0, 10, 11, 12, 13, 14, 15, with 15 being the last one. The externally accessible function code is 03. The station address is 1, and we have 15 accessible data points for holding registers. Modify the holding registers one by one. Change the first holding register address to 11 and the last one to 15. Hit Reset. This reset is for the master station modification. Inside Modbus poll, connect to the server on the left. Click Connect, select Modbus TCP/IP. The server address we're accessing is also 127.0.0.1. We need to enter the address of the Modbus server we want to access. Access it through port 502, which needs to match the 502 on the left software. Keep other parameters as default and click OK. Create a connection to access the data in the server. Click New. By default, we start accessing its data. It uses function code 03 to access station address 1 by default. Click the top left corner of the table, right-click, and select Define. Here, we can modify the station address we need to access. We need to access the server's data with function code 03. The starting address we need to access is 0, and the number of holding registers we want to access is 10. We can change it to 16. We can also modify the access frequency. Now it accesses once per second. We can make it faster, accessing once every 100 milliseconds. At this point, modify the data on the left, change the second holding register's data to 22, and click OK. After that, check this position to see if the data read will be updated immediately. Click OK, and the data is updated right away. Click Display Communication, and here we can see the data sent by the client and the data received by the server. Click Stop, and we can see that this is the data sent by the client, TX. And the frame of data below is the data received by the client. The assignment for today's lesson is to take these two frames of data and analyze them, understanding what each byte represents. In this lesson, we have learned about the Modbus TCP frame structure and clearly understood the frame structure through an example. The assignment for this lesson is to analyze the data sent and received by the client. See you all next time.